It's another math day here with teacher Jenny. Join me for another topic. And this time we're going to talk about writing standard equation of the parabola with the given endpoints of the latus rectum. First, once you are given with the endpoints of the latus rectum, all you have to do is to identify first the opening and note that the direction of the movement of the endpoints of the latus rectum from the focus will always be different from the direction of the opening of the parabola. So let's say, for example, if your endpoints are moving from left to right of the focus, which means that the opening of the parabola could be either upward or downward. And vice versa, if your endpoints of the latus rectum is traveling from the focus to an endpoint of the latus rectum up and down, which means that the opening of the parabola is either left or right. So the determinant as to what specific opening could that be will be dependent on the A value here. So that is why we can see an A value here indicator. You can either have A less than 0, which means that's a negative. A greater than 0, that means to say that's a positive. Okay, let's start off with number 1, opening. We need to identify the openings. So starting off with the endpoints of the latus rectum at 2, 8, and 2, negative 4. So as you can see, we have clearly seen that the x values are the same. So which means that our endpoints of the latus rectum is traveling up and down from the focus. So which means that it's either left or right is our opening. So let's try to find out. And we can identify that one right away as to whether it's left or right is the opening is by simply looking at A here with an A which is less than 0. Since A is less than 0, that means to say we are having here a negative, and the negative direction of that opening is to the left. If you try to look at this is also an indicator. Your symbol there, the less than symbol, if you try to look at that one, the tail there is pointing to the left side. So which means that from there also you can identify that the opening is really to the left. If you've got that one as left or right. So anyways, let's try to plot the endpoints of the latus rectum here. So locating our x equal to 2, this is where x equal to 2 is. And we've got 8, 1 on y, 1, 2, 3, 4, 5, 6, 7, 8. This is where our y equal to 8 is. And negative 4 on y, we've got negative 1, negative 2, negative 3, negative 4. So plotting the points, we've got 2, negative 4. That will be somewhere here. This will be our endpoint of the latus rectum. And we've got another one with 2, 8. This is also here. So as you can see, that's traveling up and down based on our focus, but we don't know the focus in there. But let's find out the opening really is. So we've got up and down as the movement of our endpoints of the latus rectum. So we need to say it's either going to be opening to the left as our parabola is and opening to the right. So let's now have this A value. This is pointing to the left, so which means that we're following a left opening of the parabola. So most likely like this. This is just an assumption of the parabola as how it is going to be with respect to the opening of the parabola. So we've got that one as a left. Anyways, I'll erase that one because we'll be identifying later on our vertex and the focus. So again, without the focus yet, and so with the value of A, we cannot identify the vertex yet. So again, opening is left. Let's now identify our A first. But one thing is for sure, that the endpoint of the latus rectum, if these are your endpoints of the latus rectum, this distance from that endpoint to another endpoint, that is equal to a 4a, or simply saying that's the length of the latus rectum. So 4A, so literally we're just counting off the number of units from here to here. So we are counting off from this one. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got 4A, which is equal to 12. So from there, we can divide this by 2 first. Why divide this by 2? Because we need to identify our focus. And take note, our focus is located in the middle of those endpoints of the lattice rectum. So literally, we're just dividing this by 2. And so with this by 2 to get our 2A. And take note, from the focus to one endpoint. So let's say this is our focus here. From this one to this one, that is 2A. So we need to identify the focus because we cannot identify the vertex without the focus. So here we've got 2A is equal to a 6. So meaning we're counting off from one endpoint to where the focus is as 6 units. So we start off from one endpoint here might be. We have 1, 2, 3, 4, 5, 6. This is where our focus is. Or to say that one, we can simply apply our midpoint formula there. Since we've got the same value on x, which is 2, if you are adding that one and dividing that one by 2, you'll still get a 2. So that is why to get it right away, we just have to make use of those different values. We've got that one on the y, so we have 8 plus the negative 4. We're dividing that by 2. 8 plus negative 4, that's a 4. Divided that by 2 is a 2. This is the y value for our focus. So identifying our coordinate for the focus, we've got that one as 2 and 1, 2. This is a 2 here. So focus is at 2 and 2. Now let's now identify our vertex. To identify the vertex, we have to know our A. So we're dividing this by 2. So our A there is a 3. So from the vertex, we're counting off 3 units towards the vertex. But to where? Is it going to be to the right or left? Now notice that we are following the opening of our parabola based on where the focus is. So if this is to the left, that means to say that we will be moving towards the vertex opposite to that opening. So we will be counting off 3 units to the right. So this is from the focus. We have 1, 2, 3. This is where our vertex is. And identifying the coordinate of that one, this is 3, 4, 5. This is 5 on x. And then, of course, same value on the y on the focus, which is a 2. Our vertex now is at 5, 2. So we are with the vertex already. So we've got 5, 2. And then our A is 3. Our 4A is, of course, we've got that from the very start, which is the 12. So we are now ready to write down our standard equation of the parabola. So we start off with identifying the opening that's left. So we start with a y minus k squared equal to, this is to the left, we're facing negative numbers towards the left side. So negative 4a times x minus h. Then replacing, this is our h, this is our k. Y minus our k is 2 squared equal to negative, replacing our 4a, which is 12, times x minus our h is 5. This is now our standard equation of the parabola. Okay, we've got number 2. Focus is at 5, 3, and the rectrix. Oopsie, that's not the. So this is really the given a number 2. We're on T. Our given are the endpoints of the lattice rectum. So we have 0, 1 and negative 8, 1. And our A is greater than 0. So that means to say it's positive. So plotting our endpoints of the lattice rectum, but before that one, we can clearly see that the y value here are the same. That means our movement of the lattice rectum from the focus is left to right. So we're expecting that our opening there is upward, downward. But since we've got a greater than 0, which is positive, so yes, so we are expecting that that should be an upward. And then let's try to plot because we need to identify our 4A for that one. So 0, 1, we are locating our point there on the y-axis where y is equal to 1. So that is somewhere here. And then we've got negative 8, 1. So on x, we have negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. This is where negative 8 is. And our other endpoint is here. So based on that one, we're counting off the number of units that they are away from each other. So from this point, we've got 1, 2, 3, 4, 5, 6, 7, 8. So our 4A here is an A. So right away, we've got 4A. So we can identify first our 2A to get to where the focus is. Our 2A, 4A, we divide out 1 by 2 to get to 2A. That's equal to 8 divided by 2, which is a 4. Now, counting off again to get to where the focus is from one endpoint. So let's say we start here. This is 1, 2, 3, 4. This is where our focus is. And taking note that our opening of the parabola is upward. So literally, we are counting downward to where the vertex is. So first, let's identify our A by dividing this by 2. A here is 4 divided by 2, which is a 2. So we are now with our A equal to 2. So let's count off from the focus, going to the opposite direction as to what the opening is. Since that is upward, we're counting downward to get to where the focus is. So from the vertex, from the focus, we count 1, 2. This is where our vertex is. And identifying our coordinate for that, we've got negative 1, 2, negative 3, negative 4. Our x is with negative 4 and a 1 on y. So we've got now vertex with negative 4, 1. We have our h and our k for that one. So we are now ready to write our standard equation. This is upward, so we have x minus h squared equal to upward. That's leading to a positive value. So that's positive 4a times y minus k. Replacing everything, we have now x minus our h is negative 4. So that will be a plus 4 squared equal to our 4a is 8 and y minus our k there is a 1. No, that's not actually a 1 but a negative 1. I'm so sorry on that one. This is where negative 1 on y is. I got mixed up on that one. So we've got vertex at negative 4 and negative 1, by the way. And of course, since our k is negative 1, so that means to say that this should be a positive 1. So there you go. We've got our standard equation of the parabola. We are now on number 3. Opening is going to be determined by simply looking at the endpoints on number 3. We have negative 5, 3, and 11, 3. So we have the same value on y. So which means that our endpoints are traveling left and right from the focus, which means that the opening is either upward or downward. So to identify that one, we have our a less than 0, which means that our a value is negative. So that is downward. So we have now the opening here as downward. We are now ready to identify the vertex and the A and the 4A. So let's now plot our latus rectum. But since we've got 11.3 here, we will be scaling our Cartesian plane here into 2 units per grid. We start off by identifying negative 5 and 3. So this is negative 2. This is negative 4. So negative 5 is in the middle of that one. And we've got 3 on Y. So this is 2 and then 4. So 3 is in between 2 and 4. So this is where our point is for the endpoint, the other endpoint of the latus rectum. And then we have 11.3. So identifying that one, this is 2, 4, 6, 8, and 10. This is 12. So 11 is somewhere in the middle of those two. And then we have 3 as well. So this is going to be where our other endpoint is. So there you go. We've got our endpoint and counting off the number of units away from each other. We've got here one endpoint. This is going to be counting off 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16 on our other endpoint. So our 4A there is 16. Now, if you are having trouble because you're scaling down your grid lines, then you can simply just get the distance of those two. Take note, our Y value there, we have the same value, so we don't bother getting the distance or subtracting those two. We just simply have to do subtract our X values, which are the different values there. So we can do negative 5 minus 11. And that will give off the distance on that particular variable, which is the X. So negative 5 minus 11, that's negative 16. Get the absolute value of that one, which is 16. So that's the distance from one endpoint to another endpoint, which is our 4A. So we are going to divide this by 2 to get to where the focus is. So we have 2A is 8. So we're counting off from one endpoint towards the focus 8 units. So we have 1. Let me use another color. So we have from the one endpoint, we have 1, 2, 3, 4, 5, 6, 7, and 8. This is where our focus is. And to identify that one that is with a coordinate, which is, this is supposedly 2 here. So the coordinate of that one is at 3 and 3. So that's our focus. You can double check that one by simply looking at our different values, and then you can just simply get the midpoint of those different values, because if you are going to get the midpoint including the 3 here, you'll still get a 3. So that is why I advise go to the different values and then simply add them up. Negative 5 plus 11, and then divide that one by 2. Negative 5 plus 11, that's a 6. Divide that by 2, that's a 3. This is actually the value of your X. So see, we've got an X value here, which is a 3, and we're sharing the same value on the Y, which is a 3. So we have now the focus. We are down with the vertex. Now, noting that the opening here is downward, so which means that from the focus, which is somewhere here, we are moving to the top. How many units? We need to find out by simply dividing this by 2 to get to to get our A value. Our A here is a 4. A is 4. So we can now identify the vertex by simply counting off from the focus, moving to the opposite direction as to what the opening is. So since that's downward, we move up 4 units. So from here, we have 1, 2, 3, and 4 because we're having here 1 grid line, 2 units. So this is where our vertex is. And to identify our coordinate for that, we follow the same x value on the focus, which is 3. And on y, we need to identify this one here in the middle. So since this is 4, this is 6, this is 8. So the one in the middle is a 7. So we've got vertex is at 3, 7. Okay, we're done with the vertex. So we are to identify the 4a. So 4 times 4, that's equal to 16. And then writing the standard equation of the parabola, we are to take note the opening that's downward. So we are to start off with x minus h squared equal to downward opening that will lead to a negative number. So that's negative for 8 times y minus k. And then our h here is 3, our k is 7. Replacing everything that is there except for the x and y. X minus our h is 3 squared equal to negative 4a is 16 times y minus k is 7. So that is what we have for the standard equation of the parabola for number. We're now on number 4. So let's start off with the endpoints of the latus rectum at 3, 0, and 320. So again, it's a very big number value on y. So we will be scaling down our grid line into 2 again. So one grid line is 2. So we have here same value on x, which means that our endpoints are traveling up and down from the focus. So opening could be right or left. So here we've got our a value which is greater than 0, so which means that that's positive. So between left and right, right has positive values. So we have the opening now at the right. Plotting our points on the endpoints of the latus rectum, we have here our 2, we have 4. So our 3 here is going to be in between 2 and 4. So since we've got there 3, 0, so we'll be plotting our first endpoint here in the middle. And then we've got 320. So this is 2, 4, 6, 8, 10. I think it's not going to be even enough. 12, 14, 16, 18, and 20 will be the last one, the last grid line. So we have now 320 is around somewhere here. There you go. It's going to be 320 there. Um, so this is why it's going to be difficult to count at 1. So we'll just go off by simply getting the midpoint of that one, or getting the distance of that one, because it's hard for us to count because of the grid line there. And so with the last value on y equal to 20. So here we'll start off with identifying first the 4a. We can get the 4a by simply subtracting our values on the y, which are different values. So we can start off with a 0 minus 20. And then 0 minus 20 will give that as negative 20. Get the absolute value of that one, which will make this one as a positive value. So our 4a is positive 20. So there we've got positive 20 as our 4a. And then we are going to identify the focus by simply dividing this by 2 to have our 2a. So our 2a there is Our 2a there is equal to 20 divided by 2 is 10. So basically, since we started off with y equal to 0 here, that means to say once we count it off at the top, we're moving to the top, the focus will be somewhere where y is equal to 10 is. So this is where our focus is. And the coordinate of that one is at 310. Now, identify the vertex, we divide this by 2, and so with that 1, our A here is equal to a 5. So we have now our A as 5. So getting to the focus, we move opposite to the direction of the opening of the parabola. Opening is to the right, so we move to the left from the focus. How many units? We have 5 units for that one. Starting off with the 1. Let me change color. 1 here, and 2 in the middle, 3, 4, and a 5. So this is where our vertex is. And the coordinate of that one is, our x there is with a negative 2. And our y value is the same as your y on the focus. So we have negative 2 and 10. So let's try to check because our graph is not that visible. So let's try to check by simply using the midpoint of our midpoint here, which is our focus. So to identify the vertex of that one using our focus, we literally just focus on the movement. The movement is to the left, so that is why we're focusing on 3. Because what will change once we move to the left is the x value. So moving to the left, we just simply have it as 3. Moving to the left means a minus, and we have our A as 5. Then we simply copy the value of y on the focus, which is 10. This will be our coordinate for the vertex. Simplifying that one, we've got now 3 minus 5. This is negative 2, and y is a 10. So we're correct to say that that is negative 210 as our vertex. So since we're complete with all that we need, so we are now going to write our standard equation of the parabola. Let's start off with the opening. That's right. So that means we have y minus k squared equal to positive for a because that's to the right. We're moving towards a positive number. And then times x minus h. Replacing everything on the equation, we have y minus our k there. This is our h. This is our k. Our k is 10 squared equal to, by the way, that's not 40. That's 20. Sorry on that one. Where am I looking at? This is 20. Ah, yeah. I got confused on that one. That's a 4A. Really? Okay. I thought that was 4T. Okay, 4A. Now, replacing our 4A, we've got a 4A here, which is equal to 20. So we replace that one with 20. And then times x minus our h there is negative 2. So instead of minus 2, that will become a plus 2. So we have there our standard equation of the parabola. Okay, so we'll start off with number 5. Looking at this, we have the same value on y. So we're moving, the endpoints are moving to the left and right from the focus. So which means that we're expecting an upward, downward opening of the parabola. And looking at your A is less than 0. So which means that our A is negative. So that would simply mean that we have that as opening to the left. So we are now going to identify the vertex, but before that one, let's identify first our 4A by simply plotting our endpoints. 0, negative 2, 0, negative 2, negative 2 on y-axis. We're going to locate that one and plot the 0, negative 2. So this is where 0, negative 2 is as one endpoint. Then we have negative 8, negative 2. This is negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. Negative 8, negative 2, this is somewhere here. So it's really clear that our oh no. I think I was mixed up with the one that I wrote there on my opening. Okay, again, going back to what I mentioned, um, since our value on the endpoints of the lattice rectum, you've got there with a y which is the same. Our x is different, so which means that our endpoints of the lattice rectum is moving to the left and right of our focus. It's opening up and down. The parabola is opening up and down. So since we've got a negative here, that means it's opening downward. Because I was looking at the symbol here, which is pointing to the left, so that's why it has a left in there. Anyways, moving on, so we've got to identify 4A. So we just simply count the number of units from each of from away from those endpoints. So we start off from one endpoint, counting off 1, 2, 3, 4, 5, 6, 7, 8. So that means we've got 8 units away from those two endpoints. So we've got our 4A here as 8. So we are now going to identify our 2A by dividing this by 2 to know where the focus is. So 2A is equal to 8 divided by 2, which is a 4. So identifying by counting off from one endpoint. So let's start here. 1, 2, 3, 4. This is where the focus is. The focus is at negative 1, negative 2, negative 3, negative 4, and then negative 2. So that's the focus. And then after identifying the focus, we are going to divide this by 2 to know what is the value of A to identify our vertex. So A is 2. Identifying the vertex, we go opposite to the direction of the opening of the parabola. Since the opening is downward, we move up to where the vertex is by counting from the focus 2 units. 1, 2, this is where the vertex is. Vertex is with a coordinate which is negative 4, and of course, it's on the x-axis, so our y value is a 0. So we have our vertex negative 4, 0, where h is negative 4 and k is a 0. So we're now ready to write our standard equation. So we are to start off with the opening downward. So starting off with the x minus h squared equal to downward. That's moving to a negative number. That's negative 4a times y minus k. Replacing everything, we've got x minus, our h there is negative 4. So this means that we are to have a plus 4 here, squared equal to a negative. Our 4a is 8. And then we have times y minus k is 0. Simplifying that, it's not yet the final answer. X plus 4 squared equal to negative 8y. That's how you are going to write your standard equation of the parabola. So this is your teacher Jenny saying practice and practice and practice, and you'll get perfect one day.